Okay, so question 14 says, as a tennis ball is struck, it departs from the racket horizontally with a speed of 28 meters per second. The ball hits a court at a horizontal distance of 19.6 meters from the racket. How far above the court is the tennis ball when it leaves the racket? Okay, so we start off by drawing our diagram, and we see that's a cliff-style problem. So we already know a lot of the properties here. So for our x components, we know that our initial velocity is 28 meters per second, because this tells us that the racket strikes the ball horizontally at a speed of 28 meters per second. Final velocity is the same as the initial velocity, and our acceleration is 0 meters per second squared. We know our distance that they gave us, the horizontal distance, is 19.6, and we don't know our time. For our y components, we know that the initial velocity in the y is 0 meters per second, because we know that's a property of the cliff-style problems. The final velocity we don't know, and the acceleration in the y is negative 9.81 meters per second squared. We don't know our distance or our time here. So, first of all, we need to start off by solving for our time. We know that the x component and the y component share the same time. So if we can solve for the time, then we can use that time to solve for the displacement in the y. So we start out with the equation that our displacement is equal to 1/2 of our initial velocity plus our final velocity times our time. So we plug in our x components, or x variables, and we get that the time is equal to 0.7 seconds. Then we plug that time into our equation of our displacement is equal to our initial velocity times time plus 1/2 of our acceleration times our time squared, and we plug in our time along with our y values to get that the displacement in the y is equal to 2.4 meters. Or this is, they gave us the answer in negative, but it's asking us how far above the court the tennis ball is when it leaves the racket. So we know it's going to be a positive 2.4 meters.